We present a robotic gait orthosis for cerebral palsy children. Passive gait orthoses are wide-used assistive devices that help the user to support the body and may apply mechanical reciprocation. Unfortunately, these devices may be not sufficient for fluid and autonomous walking, and external help from a therapist is often needed. Our prototype overcomes some of the limitation of these passive devices. The design concept is that it is the user itself that drives the orthosis and plans the motion. This is achieved by assistance as needed and intention recognition, which both rely on compliant motion control. Compliant motion control allows eye transparency of the device and let the patient free to move, to make errors and to learn. As a result of such a design, we show this video, taken after some training with the robotic orthosis. In the end, our test patient was able to keep a fluid, autonomous walking, and also to start it without any external help. During this training, the patient experienced augmented biofeedback over movements. In fact, his wheel of movement actually translates into a fluid gait pattern. This closes the patient biofeedback loop and puts him in a favorable condition for learning. As a consequence, after further training, the patient was able to autonomously drive the orthosis in a passive configuration, where the actuation system is switched off. As a comparison, one can observe the difference with respect to the initial condition of the patient, where he needed external help from the therapist and showed a less fluid walking. With this research, we showed encouraging learning results in a single case study using a novel robotic orthosis which is able to put the patient in a favorable condition for learning. As a future work, we plan to substitute the two pneumatic muscles with a single serious elastic actuator, thus improving energy efficiency and force control performance. Also, we plan to implement a novel force planner, which further improves usability of the orthosis. These suggestions for improvement are supported by theoretical analysis and scientific publication by the Altair Robotics Laboratory.